Right now, you are experiencing something. There is a particular quality to this moment. The color of what you're looking at, a faint sound somewhere behind you, the specific feeling of whatever you're sitting on. These experiences are real. They are happening. And science has absolutely no idea how. Not, we're still working on it. Not, we're getting close. After more than a century of neuroscience, after mapping every synapse in the human brain, after building computers that can beat us at chess and write poetry, we have no explanation for why any physical process gives rise to experience at all. You're watching Infamyx. Join me today as we investigate the one question that keeps the world's sharpest minds up at night, and discover why the closer we look at consciousness, the stranger it becomes. And the more we learn about it, the stranger it becomes. For most of scientific history, consciousness wasn't even considered a proper research question. In the early 20th century, the behaviorist movement, led by psychologists like John B. Watson, argued that science should only study what it could observe: behavior, outputs, measurable responses. What was happening inside was too fuzzy, too subjective, too unscientific to touch. That changed in the 1990s. Neuroscience had advanced far enough to start mapping which brain regions activated during different mental states. Suddenly, consciousness felt tractable. By 2000, Francis Crick and Christoph Koch at the Salk Institute had proposed that consciousness arises from specific oscillating patterns of neural activity, firing at around 40 times per second. It sounded like a breakthrough. In this video, we'll trace exactly why that promising lead, and every theory that followed it, kept running into the same invisible wall, and what that wall tells us about the nature of reality itself. But to understand why every answer fails, we first need to understand what the question actually is. There are actually two separate problems here, and science has confused them for decades. The first, what philosopher David Chalmers in 1995 called the easy problems, involves explaining how the brain processes information, controls behavior, integrates signals from the senses, directs attention. Think of it like building a very sophisticated thermostat. You can add more sensors, more feedback loops, more complexity. Eventually, you get a system that responds to the environment in increasingly nuanced ways. Every function is explicable, every behavior traceable. And neuroscience has made extraordinary progress on exactly this front. We can trace the path a visual signal takes from your retina through the thalamus and into the visual cortex. We can identify the precise brain regions that activate when you recognize a face, feel pain, or retrieve a memory. These are remarkable achievements. But here is the problem. None of that explains why there is something it feels like to see a color. Explaining how the brain processes the wavelength 700 nanometers doesn't explain why it looks red to you. Describing the neural response to a C# doesn't explain why music can make you cry. The easy problems explain what the brain does. They tell us nothing about what the brain experiences. And that raised a deeper question. Maybe the answer wasn't in function at all. Maybe it was in the physical hardware. The most intuitive theory of consciousness is also the oldest. You are your neurons. This view, sometimes called neural identity theory, holds that mental states are nothing more than physical brain states. Your experience of the color red just is a particular pattern of firing neurons. It's a deeply compelling idea. Damage specific parts of the brain, and specific experiences vanish. Sever the connection between the two hemispheres, and you effectively create two separate streams of consciousness in one skull. The brain and the mind track each other with extraordinary precision. It's hard to deny they're deeply connected. But there was one problem no one could solve. Even if we granted that every detail of neural activity was mapped perfectly, every neuron, every synapse, every oscillation cataloged, you would still be left with the same gap. The description would be complete, and yet you could still coherently ask, but why does any of this feel like anything? The philosopher Joseph Levine called this the explanatory gap in 1983. The neural data tells you everything that's happening. It doesn't tell you why it's experienced. So if the specific hardware couldn't explain consciousness, maybe the answer was something more abstract, something about how information is organized. The second major theory argued that consciousness isn't about neurons specifically, it's about complexity. Think of it like the difference between a light switch and a city. A light switch processes information, on or off. A city processes information in a million simultaneous ways. Traffic, economics, communication, power grids, each subsystem feeding back into the others. The argument goes, at some threshold of complexity and integration, consciousness simply emerges, like wetness emerging from water molecules, or life emerging from chemistry. This view gained serious ground in the 1980s and 90s. Researchers like Daniel Dennett argued that consciousness was not a special ingredient, but a natural byproduct of information processing at sufficient scale. If you build a system complex enough, you get experience for free. It's elegant, and it has one devastating problem. Complexity explains behavior. It does not explain experience. A weather system is extraordinarily complex, far more integrated than a human brain in certain respects. No one seriously proposes that a hurricane experiences anything. The internet processes more information than any human nervous system. We don't believe it feels anything. Pointing at complexity and saying, consciousness comes from that, is a bit like pointing at a fire and saying, heat comes from that. True, but useless. It doesn't explain the mechanism, it just relabels the mystery. Both major theories had failed, and that brings us to what might be the most important shift in the philosophy of mind in the last 100 years. In 1995, the Australian philosopher David Chalmers published a paper that reframed the entire debate. Chalmers argued that all previous theories had been answering the wrong question. They explained cognition, processing, behavior, integration. What they consistently failed to explain was what he named the hard problem of consciousness. Why is there subjective experience at all? Here is the cleanest way to feel the force of this. Imagine a being, call it a philosophical zombie, physically identical to you in every way. Same neurons, same brain activity, same behavior. It responds to pain, discusses its emotions, writes poetry. But inside, there is nothing it's like to be it. The lights are on, and no one is home. The hard problem asks, what is it that makes you not a philosophical zombie? What adds the felt quality to the physical process? No scientific theory so far has answered this. And that changed what scientists began looking for entirely. The most serious current attempt to answer the hard problem comes from neuroscientist Giulio Tononi at the University of Wisconsin-Madison. In 2004, Tononi proposed Integrated Information Theory, IIT. It holds that consciousness is identical to a specific property of information systems he calls phi, a measure of how much integrated, irreducible information a system generates. The higher the phi, the more conscious the system. A rock has near zero phi. A sleeping human has moderate phi. A waking, attentive human has high phi. What makes IIT genuinely different is that it doesn't try to reduce experience to physical processes. It takes experience as the starting point and asks what physical structure could generate it. But IIT leaves the door open on questions that may define the next century of science. If phi is the measure of consciousness, Does that mean certain AI systems are already conscious? Does it mean some animals experience reality in ways richer than we assumed? And does it mean the question of what we owe to other minds, human and otherwise, just got considerably more complicated? Science hasn't solved consciousness. It has learned, with great precision, exactly how hard it is to solve. And that, it turns out, is its own kind of discovery. The deeper we look, the more it seems that consciousness isn't a puzzle waiting to be solved. It's a mirror, and what it reflects back at us is something we didn't expect to find at the frontier of neuroscience. The irreducible fact that experience exists, and that no account of the physical world, however complete, has yet explained why. If this video made you think differently about something you thought you already understood, there's more where that came from. Infamyx is built around exactly these kinds of questions, the ones that seem simple on the surface and turn out to be the deepest thing you've ever looked at. Hit subscribe and join me for the next one.